All right, so let's tackle the next two. So these are building on what we looked at in the previous two problems. If you take a look at the pattern here, what's happening every time is we are subtracting 5. To get from one term to the other, we subtract 5. Now, in the previous videos, if you look back at the videos for problems 2 and 3 and 4, I think, we talked about what to do when you see this repeated addition or repeated subtraction. It's going to be some kind of arithmetic sequence. It's going to be like a linear function. And if you go back to what you did in Algebra 1, this, let's label these again. This is when n is 1, when n is 2, when n is 3, when n is 4, and when n is 5. And maybe if you write that there, you can say, okay, what did we do with n to get -8? And there's a lot of things you could do, right? But then we have to take into account, we have to do the same thing to n to get -13 when n is 2. And maybe you can reason through it that way, especially since it is linear, because it has that rate of growth that's either adding or subtracting a number every time. Or maybe you remember back to Algebra 1, and you remember how in Algebra 1 you wrote an equation for an arithmetic sequence that had something like this. You took your 0 term and you added whatever your rate is times n. And that's really pretty much what you did in Algebra 1. I'm just using our terms now, a sub n and n instead of y and x, or whatever we might have used in Algebra 1. So we have to think about what each of these things are. Now, as far as our 0 term goes, I don't really have that written down, but I can easily find it. I know what my first term is. To find my 0 term, I just need to go backwards 1. So if I go backwards 1, so instead of, if I'm going this way now, instead of this way, I'm going to add 5. So I'm going to take -8 and add 5, and that's going to give me -3. That's my 0 term. So I know my 0 term is -3. Your rate is that difference between each term, or each pair of terms. So what are you doing to go from one term to the next term? In this case, we're subtracting 5 every time. So then if I want to write that equation, a sub n equals -3 minus 5 times n. And that's one way that you could write this. There's a number of other ways. You might have just been able to reason through this, knowing that it was linear, and recognizing that you're subtracting 5 each time. You may have recognized that, oh, that means I'm going to be multiplying by -5 in some way. If not, again, this is one of those things, guys, I don't want you to panic if you didn't do well on this one. This just takes time and practice and recognition of patterns. That's all. Okay, so then you have this next one, which is not linear. And you can almost tell that just by how quickly the numbers are growing. We go from -4 to -1024 in 5 steps. So it's not linear. It's growing by some other rate. Let's look at that. So, once again, I'm going to write out here what n is. We've got n is 1, n is 2, 3, 4, and 5. So you can think about this, what happened to get -4 when n was 1? What happened to get -16 when n was 2? Let's look at our rate of growth, okay? So what do we do to get from -4 to -16? Well, you're multiplying by 4. You might also say, well, you could have also subtracted 12, Mrs. Kopp. Right, but we already kind of established this is growing too quickly to be linear. So adding or subtracting something probably won't work. And if you thought, well, I can subtract 12, when you try that to this next set of terms, it's not going to work. So you can immediately recognize you're not adding or subtracting that number. But then if I look at -16 to -64, I'm multiplying by 4 again, multiplying by 4 again, multiplying by 4 again. And this is a lot like what was discussed in that problem from a couple problems prior, where we recognize that we're multiplying by something. That's telling us that we're dealing with some kind of an exponential function. What we know at this point is that a sub n has to be something that uses 4 to the n power. Now, there's a lot of ways that you can go from there. What I can say is, all right, if I've got 4 to the n power, well, okay, let's play this out. What if that's my equation? Okay, so what if a sub n equals 4 to the n works? Okay, well then when n is 1, what would I get? I would get a sub 1 equals 4 to the first power, which is 4. Well, that's not quite right. It's close, but it needs to be negative 4. So what could I do to negative 4, or to 4? What could I do to this answer to make it look more like this? Well, I could multiply by negative 1. Okay, well, let's see if that works. So if I were to then multiply this by negative 1, that means that I would have had to have multiplied the original equation by negative 1 as well. So what if that's it? Okay, so now what if, so we recognize that wasn't right at first, but what if it's now a sub n equals negative 1 times 4 to the n? Okay, so when n is 1, what do we get? We get a sub 1 equals negative 1 times 4 to the first power, which is negative 1 times 4. Oh, that works. Well, what if n is 2? Okay, so then a sub 2 equals, negative 1 times 4 squared, which is negative 1 times 16, which is negative 16. Ooh, that works also. Try one more. What if n is 3? Well, then a cubed equals negative 1 times 4 cubed, which is negative 1 times 64. Ah, that works. So our equation is that, negative 1 times 4 to the n. And sometimes that's the process you have to do. You have to sort of think about, what's my base equation here? What's happening? Well, I know that I'm multiplying by 4, which means I have 4 to the nth power. From there, adjust that to get the terms that you need to get.